Hi friends, good morning to everyone. Have you gone through the yesterday session? Have you any doubts in the yesterday session?
Good morning, sir.
Good morning, Vigneshwaran. Have any doubts?
No, sir.
Okay, in this session we explore operators first and then we solve the problems. Please take it. Operators in the C language. C provides a rich set of operators. First, let us explore the arithmetic operators. To perform the arithmetic operations, plus, minus, star, slash, modulus. We can use these operators. Plus is for addition, minus is for subtraction, star multiplication, slash, right? This is for integer division as well as a floating point division. Then percentage symbol. This is the modulus operator. Modulus operator. Plus, which is served for the binary operator. For example, C is equal to A plus B. A is the left hand operand, left hand operand, and B is the right hand operand. Plus is the binary plus operator. This is the binary plus operator, which takes two operands, left hand operand as well as right hand operand. It performs the arithmetic plus, and the result is assigned in the variable C. Likewise, minus, star, slash, modulus. These are said to be binary operators. Plus and minus also serves as unary operators. For example, we can write int x is equal to 5. This is same as int x is equal to plus 5. Here this plus serves as unary plus, that here in C is equal to A plus B, here this operator plus is a binary plus. Here this plus is unary plus. That means the sign of 5 is taken as plus. By default, here the sign of 5 is taken as plus. So you can write the C is equal to A or C is equal to plus A. Both are same. There is no change in these two assignment statements. C is equal to A and C is equal to plus A. But unary minus operator is concerned. Suppose C is equal to A, C is equal to minus A. Here what is the meaning? C is equal to A means the value of A is assigned to C. C is equal to minus A means this is actually C is equal to A into minus 1. The value of A is multiplied by minus 1 and the result is assigned to the left hand side variable C. So in this case, here this minus serves as unary minus. We can write x is equal to minus 5, x is equal to plus 15. This is unary plus, this is unary minus. That means the value minus is assigned, right? Minus 5 is assigned to the left hand side variable x. That's what here we have c is equal to minus a. This is same as c is equal to a into minus 1. So unary operators are right, two operators, one is plus and minus. Unary operator takes this general form. Operator operand where operator takes either plus or minus. Where in case of binary operators, here the general form is operand 1, then operator operand 2, where the operator takes any of these values plus, minus, star, slash, modulus. With respect to slash, right, already we explored int x is equal to 1 by 3. Here the operands are of integer by integer, so integer mode is evaluated. X receives the value 0. Because numerator is an integer 1, denominator is an integer 1, integer division is carried out. If we write float x is equal to 1.0 by 3, numerator is 1.0, a floating point quantity, denominator integer, so the denominator is type promoted to a floating point 1, 1.0 by 3.0, the fractional evaluation is carried out and the result is assigned to the left hand side variable x. So here slash serves for the division operation to perform both integer division as well as a floating point division. Then the modulus operator is concerned, right? Percentage. This is the modulus operator, which returns a reminder after performing the integer division. After performing the integer division. Suppose 5 mod 3, it returns a value 1 into 3, 3, right? Reminder is 2. 3 mod 5, quotient is 0, reminder is 3. 5 mod 5, what happens? A reminder is 0. So already right, we have returned the statement equations x mod x is equal to x for all x mod x. What is x mod x? X mod x is 0, right, for all x, because the quotient is 1, reminder is 0. Then x mod y is equal to x if x is less than y, where x and y are integers. In C language, the percentage operator, this is applied only when the left hand and the right hand operands are of integer type. This is one important restriction. The operands must be of the integer type. So these are the basic arithmetic operators. Then next one is the relational operators. To compare two quantities, right, x and y, we have the list of relational operators. X is less than y, x is greater than y, x is less than or equal to y, x is greater than or equal to y, x is equal to y, x is not equal to y. So the relationship, right, this is less than, this is greater than, this is less than or equal to, this is greater than or equal to, this is equal to, this is not equal to. For example, if we have x is equal to 10, y is equal to 20, or y is equal to 20. You can compare, right, if x is less than y. For example, if x is less than y. This is said to be a relational expression. Relational operators are used to form the expression called relational expression. The outcome of relational expression is either true or false. If x less than y, right, condition is true. 10 is less than 20. Suppose x is 100, 100 less than 20, condition is false. So likewise, whatever the relational operators, right, we are using less than, greater than, less than or equal to, greater than or equal to, is equal to, then not is equal to. These are relational operators. To strictly compare two quantities x and y, right, you need to use any of these two operators. If x is equal to y or x is not equal to y. Then the next one is logical operators. There are three logical operators here, basically here. This is logical and pipe symbol, right? This is logical or logical and double ampersand. This is logical or pipe symbol. Then exclamatory symbol, right? Logical not. For example, if we combine two conditions, if A is greater than B and A is greater than C, this is one a relational expression. Relational expression one. This is second relational expression. To combine these two relational expressions, we can use these logical operators, logical and logical or and logical not. Logical and is concerned, right? In case if the first one results in true, then control checks, right, if the second relational expression is a true, because a true and a true thus results in a true. In case of the first relational expression is false, in case of logical and, control will not check the second one, because false and false are false and true, thus results in false. R is concerned a true or false results in true. Likewise, true or true results in a true. False or false results in false. Logical not just negates a true into false and false into true. Then bitwise operators. To operate on the individual bits, yes.
Sir, can you once again teach the logical operator?
Okay. See, in case of finding the minimum and maximum of three numbers, in the algorithm we have used the conditions. If A is greater than B and A is greater than C, what is this? This is the logical and. When both conditions is true. If A is greater than B and A is greater than C, for example, we can write maximum is equal to A. Now what is greater than here? Greater than is the relational operator. So if anything is formed using a relational operator, that is said to be a relational expression. A greater than B, this is one relational expression. A greater than C, this is one relational expression. What is the outcome of a relational expression? Outcome of a relational expression is either true or false. So based on the outcomes of the relational expression, we have the logical operators at table. For example, if this is the first condition, let it be A. This is the second condition, let it be B. We are writing A and B. Possibilities, right? A is true, B is true, A and B results in true. When A is true and B is false, the result is false. When A is false and B is true, the result is false. When A is false and B is false, the result is false. So that's what I have written. True and true, this results in true. Then false and false, or even write false and true, or we can write true, right? And false are true and false, right? So in the case also, right, the result is false. Logical R is concerned A, logical R, B. This is the symbol to be used. True or true, true. True or false, true. False or true, true. False or false, false. So true or false or true, right? This results in true. Only false or false. This results in false. This is logical not. Suppose A. We are writing what is called not A. When A is true, not A is false. When A is false, not A is true. These are the results of logical evaluations. Clear?
Yes, sir. Thank you, sir.
Okay. Later, right, we are going to apply all of these operators in solving the problems. Next one is bitwise operators. You have to carefully listen, right, in this session. Bitwise operators. Suppose int x is equal to 5, have another variable. Y is equal to 7. We are writing some int z is equal to x and y. Double ampersand, that is a logical and. Bitwise operators are bitwise and bitwise not, sorry, bitwise or, then this is bitwise not tilde symbol. Then this is bitwise XOR. This is bitwise and bitwise or bitwise not, bitwise XOR. First, let us construct a table A, B. This is A and B. A or B. A, simply write this is not A. Or we write not A separately. Then A XOR B. Possible values 0, 0, 0, 1, 1, 0, 1, 1. When both bits are zeros, A and B results in 0. If any one is 0, result is 0. If both bits are 1, then the result is 1 with respect to AND operation. With respect to OR operation, if any one bit is 1, the result is 1. 0 or 1, 1, 1 or 0, 1, 1 or 1, 1. 0 and 0, as 0 or 0 results in 0. A or B, A XOR B. A XOR B, right? Mathematically, we can write this one, full sum. A XOR B, this is equal to A into B dash plus A dash into B. That means A into not B, right? A and not B, right? This is further written as A and not B plus is R, not A and B. In this case, when the inputs are different, right? 0 and 0 and 1. 0 and 1 means 0 into, right, complement of 1, that is 0. Then 1 into, right, complement of 0, 1. So that here we will get 1. 1 and 0, 1. When the inputs are same, 0, 0, what happens? This XOR results in 0. 0, 0 XOR results in 0. 1, 1 XOR results in 0. Then complementary, right, operation. This is a bitwise NOT operation. A bitwise NOT. When A is 0, bitwise NOT is 1. When A is 1, bitwise NOT is 0. This is the bitwise operator statement and or not XOR. Now let us evaluate x is equal to 5, y is equal to 7. Having this operator, a single ampersand, this is bitwise AND operation. Since x is 5 and y is 7, x is 5 and y is 7, let us represent the values of x and y in the 8-bit register. Representing, right, the values of x and y in the 1-byte format or 8-bit register. 5, right, place values are 1, 2, 4, 8, 16, 32, 64, 128. These are the place values corresponding to 8 bits. Bit position 1, 2, 3, 4, 5, 6, 7, 8. Already, right, we have converted from decimal to binary. For example, 15 divided by 2. 7 into 2, 14. Remainder is 1. Then divide by 2. 3 into 2, 6. Remainder is 1. Then 3 divide by 2. 1 into 2. Remainder is 1. So 15 in decimal. This is equal to all ones in binary. So how do we have from binary to decimal? Here the place value is 1. Second bit, right? The place value is 2. Third bit, place value is 2. Fourth bit, place value is 8. Adding all these 1 plus 2 plus 4 plus 8, right? We have the decimal equivalent 15. Likewise, x is equal to 5 is represented in the 8-bit register. 8th bit 0, 7th 0, 6th 0, 5th 0, 4th 0. Third bit position is 1. Second bit position is 0. And first bit position is 1. You just think of 5. How do we get 5? Here, adding only 4 and 1. 4 plus 1 is 5. So set the first and third bit positions as ones. Remaining bits are set to 0. Likewise, how do we obtain 7? 7 is obtained, right? 4 plus 2 plus 1. 4 plus 2 plus 1. This is 7. So set the last 3 bits as 1. Remaining bits are set as zeros. This is the actual representation of 5 and 7 in the binary system. The bitwise operators are operating on the individual bits which takes the values from the set, either 0 or 1. That's what here we need to convert this into the equivalent binary representation. Now x and y, x and y. What is this and? Bitwise and x and y. Single ampersand, bitwise and. In this case, here you can find 0 and 0. 0 and 0. This results in 0. Then individual bits are considered for this bitwise AND operation. This 0 and 0 results in 0. This 0 and 0 result is 0. 0 and 0 result is 0. 0 and 0 result is 0. Then have a look into these bits. 1 and 1 result is 1. Then 0 and 1, 0. 1 and 1, the result is 1. Understand or not? With respect to AND operation, when both bits are high, that means when both bits are right 1, the result is 1. So clearly here 1 and 1, this results in 1. Last two bits 1 and 1 result is 1. 0 and 1 results in 0. Again, right, the equivalent value. For example, we are used int z is equal to x and y. Now the equivalent value is again the value 5. 5 is stored in the variable z. So z is equal to 5 is printed. If you print the value of z. This is the bitwise AND operation. Understand? Any doubt in this?
No, sir.
Likewise, bitwise R, right? In case if you like to use, suppose C is equal to X. What is the R symbol? Single pipe symbol, right? You can find right this in your keyboard. This is the R symbol, ARB. If we write C is equal to, for example, into C is equal to X or Y, then printing a value of C, how do we find? Here we write 0 or 5, 0, 0, 0, 0, 0, 1, 0, 1, 7, 0, 0, 0, 0, 0, triple 1. Writing 5 or 7, 0 or 0, result is 0. 0 or 0, result is 0. So third bit is 0, fourth bit is 0, fifth bit is 0. Sixth, 1 or 1, result is 1. Then 0 or 1, result is 1. 1 or 1, the result is 1. So here we have again the value 7, right? C is equal to 7 is the same. This not necessarily right either any one of x or y, which depends upon the individual bits, zeros and ones combinations. So if you try to take some different values for x and y, you will get different results, right, in the variables z and c. This is bitwise OR operation. Likewise, we can evaluate bitwise XOR, right, using the symbol, and bitwise NOT operation. This is the ones complement, right? When 1 is converted to zeros and 0 is converted to 1, we have the ones complement representation. Another operator is plus plus minus minus operators. These are said to be increment and decrement operators. Plus plus is the increment operator, minus minus is the decrement operator. This depends upon the usage. For example, int x is equal to 5, then if we write plus plus x means I write in comment here. Next, if we print a value of x, what happens? The roll of plus plus, which means this increments the value of a variable by 1, increments the value by 1. So plus plus x means this is logically equivalent to x is equal to x plus 1. So after this executable statement, the value of x is 6. This is said to be the pre-increment operator. Likewise, after this statement, right, please understand int x is equal to 5 plus plus x. Next, if we use the third statement as x plus plus, having these three sequential executions, here the value of x is 5 plus plus x effect is x is incremented by 1, x becomes 6. Then x plus plus, here this is said to be the post increment operation. Post increment, right? This is similar to x is equal to x plus 1 execution. So current x is 6. After that, x plus plus means x is pointing a value 7, since x is incremented by 1. In the same way, decrement operator works. Suppose int x is equal to 10. Minus minus x means after this execution, x becomes 9. X minus minus semicolon, here x becomes 8. This is pre-decrement operation. This is post-decrement operation. When you use the pre-increment or a post-increment, pre-decrement, post-decrement, expressions like this: plus plus x, x plus plus semicolon, minus minus x, x minus minus, right? Like this. The simple effect is decrementing the current value of a variable by 1 or incrementing the current value of a variable by 1. This is the effect. But when these
Sir,
operators are used, yes,
sir, I have one doubt, sir.
yes, tell me, yes,
Sir, in decrement operator, sir.
hmm.
Sir, can you hear my
Yes,
voice?
tell me,
In decrement
yes,
operator,
I am
sir,
hearing
while
you.
considering x is yes, sir. While considering x is equal to 10, we are
Hmm.
directly using a post decrement operation. We get x is equal to 8, sir.
See, x is
By
equal
applying
to
that,
10.
yes, sir.
Wait, I explain, please wait. X is equal to 10. Int,
Okay, sir.
look here, int x is equal to 10. If you write minus minus x, then printing a value of x becomes 9. Suppose int x is equal to 10. After the execution of x minus minus, here also x becomes 9. Clear? There is no change
Okay, sir.
in pre-decrement
Thank you,
or
sir. That's all.
post-decrement operation here. Even in the for loop, right, later we explore, right, the conditional control statements. We can use, right, a plus plus x, minus minus x, or minus minus x minus minus. In these situations, the effect is same. X is equal to x plus 1, x is equal to x minus 1. The effect is same. But when these operators are used in the arithmetic expression, already we explored the arithmetic expression or assignment statement. Left hand side variable is equal to expression. This is the general form of assignment statement. For example, int x is equal to 10. Assuming that one variable y is declared, if we write y is equal to plus plus x, in this stage, what is the difference? Previously plus plus x semicolon, that is one executable statement. Here y is equal to plus plus x, this is the executable statement. This is the pre-increment operator. In this case, when the pre-increment operator is applied in the assignment statement, what happens? First, the value of the variable x is incremented by 1. So here the effect is, first x is incremented by 1. X is equal to x plus 1. And then the value of updated x is assigned to the variable y. So in our case, here x is 10, then into y is equal to plus plus x means next x becomes 11. Then the value 11 is further assigned to the left hand side variable y. Y also assigning the same value 11. This is the rule of a pre-increment operation. Now consider the post-increment operation having the same statements. Int x is equal to 10, have int y, we write y is equal to x plus plus semicolon. In this case, x plus plus, this plus plus is the post increment operator. When we use the post increment operator in the assignment statements, what happens? Y is equal to x plus plus. The rule is, first the current value of the post increment variable, here for example x, this is assigned to the left hand side variable. Y is equal to x is processed first, and then the value of the variable x gets incremented by 1, or we can write y is equal to x, then x plus plus or plus plus x, whatever it is. So in this case, x is 10, then y is equal to x plus plus means the value of x is first assigned to the variable y, so y becomes 10, and then x is incremented by 1, current x is incremented by 1, x becomes 11. This is the effect of pre-increment as well as post-increment operations with respect to the assignment statements. Understand? Have any doubts?
No, sir. Thank you, sir.
In the same way, right, instead of plus plus, we can use minus minus to have the new effect with respect to assignment statements. For example, int x is equal to 50 into y is equal to minus minus x. What is the value of y and x here? Same as plus plus 6.
49, sir.
First x is increment. Yeah, first x is decremented by 1. X is decremented by 1. X is equal to x minus 1, and then the value of x is assigned to the variable y. So when x is decremented by 1, x becomes 49. Same 49 is assigned to the variable y. Suppose x is equal to 50, y is equal to x minus minus, assuming that x and y are integer variables. Here, what is x and y? Here, pre-decrement operation. This is post-decrement operation. In case of post-decrement, first, right, you need to think like this. Y is equal to x. This is the effect. Y is equal to x. That means 50 is assigned to the variable y first. And then x is decremented by 1. Next x becomes 49. Understand or not?
Yes, sir.
Okay. Then we have the shorthand assignment operators.
Sir,
Yes.
can you explain that?
Yes, tell me.
Post with an example. That example.
This
Last
one
one.
or previous page?
No,
This one.
sir. Yeah.
This one.
No, sir.
Is it correct?
Last example you
Uh,
taught, sir. Last example.
Okay. Yeah. Here, right, instead of plus plus, right, I consider here plus plus is introduced. Here minus minus is introduced. This is the pre-decrement operator. When the pre-decrement operator is introduced in the assignment statement, first the value of a variable, pre-decrement variable, is decremented by 1. X becomes x minus 1, and then the value of x is assigned to y. So here x is 50, first x is decremented by 1, x becomes 49, then the same x is assigned to the variable y, y is also 49. This is the post decrement operator. In case of post decrement operator, first the current x is assigned to y becomes x. Because of this effect, y is pointing a value 50, and then the value of x is decremented by 1, x minus minus, the effect is x becomes 50 minus 1, 40. Clear?
Yes, sir. Thank you.
Sir,
Yes.
sir,
Yes,
in
tell
the
me.
post decrement,
Yeah, in the
what
post
is the final value of y, sir? 50 or 49?
What is the, in the post
Final
decrement, what is the
value.
initial value of what? Final value of y. Okay, this is the a final value of y. Y is 50.
Okay, sir.
50 is assigned to y. Because here I said first the post decrement means current value is assigned to the left hand side variable whatever is. So the effect is this one. You need to think of this one. Y is equal to x. Current x is assigned to y. That execution is over. That means the corresponding well-defined instruction is executed. There is no change. Because of this is a post decrement operation. Further, the value of x gets decremented by 1. So you can write x minus minus r minus minus x or simply x is equal to x minus 1. All these operations are same. Then the value of x is decremented by 1. X becomes 1. You try to verify, right, these things using the same statements. Then after the assignment statement, y is equal to plus plus x. Here write a printf statement to print x and y. Here write a printf statement to print x and y. Here also, after this assignment statement, print x and y. Here print x and y. Right, you will get these results.
Okay, sir.
Okay, then a few more operators. Shorthand H. Assignment operators. When we write x is equal to, for example, x plus y, current value of x and y are added and the result is updated in the left-hand side variable x. This is same as x plus is equal to y.
Sir,
Yes,
sir, sir, I'm having a doubt in post.
yes, tell me.
Sir, at the first stage
Vignesh,
itself,
okay.
we are finding we got the first stage itself we got the answer for y, right? Then why should we proceed for taking
Yeah.
x minus minus again, sir?
See, actually, when these operators are introduced in the standalone expressions, like plus plus x plus plus, minus minus x minus minus, there the effect has been set as simply incrementing or decrementing the value of the variable. The thing is, when these operators are worked with the assignment statements, the left-hand side variable will have a significant value. In what way, right, these operators are designed to have that significant effect? In case of pre-incrementation operation, as a term, right, implies pre-increment, right? Just to think of the term pre-increment. Without performing any operation, you are asked to perform this pre-increment operation. So plus plus x means x gets incremented by 1, just like a prerequisite, right? Prerequisite to have this assignment statement is to perform this pre-increment operation. So that's what x is incremented by 1 first. And then when x is incremented by 1, you just think here, the logic is here, x is equal to x plus 1. Just think like this, x is equal to x plus 1. So x is incremented by 1, x get updated. The same value of updation is assigned to the left hand side variable y because of the board, right? Just like a prerequisite or the pre-increment. But post increment is concerned, right? Because of the boards, right? Post increment, which means we need to perform some operation first and then perform the incrementation operation. So here y is equal to x plus plus means first the instruction to be executed is assignment operation. Current value of x is assigned to the variable y, and then the variable x gets incremented by 1. Post increment after the assignment operation, increment the value of x by 1. That is the logic. In such a way, right, the operators are designed to work for same minus minus operation, pre-decrement as well as post-decrement. This is the logic behind the function of these operators. Clear?
Yes, sir.
Okay. Next, coming to this shorthand assignment operators, x is equal to x plus y. In this case, have a look into the variable x. Here x is available one time. Same x is available here. In this stage, instead of writing x is equal to x plus y, we can write x plus is equal to y. What is the advantage? The variable x is introduced one time. That's all. That is the advantage. So plus is equal to, this is said to be the shorthand addition assignment operator. Likewise, we have minus is equal to, star is equal to, slash is equal to, modulus is equal to, right? Then remaining operators here and or not, that is bitwise and bitwise or bitwise not. These can also be introduced using the shorthand assignment operators. A is equal to A into 10. This is written as A star is equal to 10. Y is equal to Y division 50. Y division is equal to 50. X is equal to X mod Y. In short, we can write X mod Y, sorry, what is the operator? X mod is equal to Y. Understand? As a term, right, shorthand, we can reduce the lengthy expression. That's all. That is the advantage. Any doubt in this?
Sir,
Yes.
hello, sir. So, is it compulsory to
Yes,
use
tell
the
me.
shorthand, or is it just like for us to use if we want?
This is yeah. This is the alternative to write the same assignment statement. Only in this case, x is equal to x plus y. Suppose x is equal to a plus b. This cannot be represented using the shorthand assignment operator plus is equal to. So just an alternative. If you need to have this as a short form, x plus is equal to y, to mean x is equal to x plus y, that stage you can use this. But this is not a mandatory one. X is equal to x plus y also works perfectly.
Okay, sir. Clear, sir.
Okay. Then the ternary operator. The ternary operator in C, right, or even C++ language is this question mark. This is a ternary operator. The ternary operator, right, it takes this general form. Expression 1, question mark, expression 2, colon, expression 3. The execution is expression 1 is evaluated. Expression 1, this is evaluated. If this results in true, then expression 2, this gets evaluated. If the expression 1 results in false, what happens? Expression 3 is evaluated. So this is an alternative flow to use the simple if statement. For example, if A is greater than B, we can write max is equal to A, else max is equal to B. This is the usage of if-else conditional statement to check if A is greater than to check if the maximum of or to find the maximum of A and B. This can be written alternately, right? A greater than B, question mark, A colon B. Left hand side we can assign max is equal to statement ends with a semicolon. So what is the advantage here? 1, 2, 3, 4. The lengthy lines of code is eliminated using the single line itself. The execution is A greater than B. This is the relational expression. If this is tested, if it results in true, this expression is evaluated and the result is assigned to the variable max. When A greater than B, if the condition is false, false block expression, that is this one. This is false block expression. This is true block expression. In this case, the expression B is evaluated. Here there is no operation, right? We have designed here. Simply write A colon B. So the value B is assigned to the variable max. Understand or not? This is said to be a ternary operator or conditional operator in C and C++ languages. Have any doubts? Have any doubts?
No, sir.
Then before going to see solving the programs or problems, let us have a look into right again expressions evaluations. Expression evaluation. How to evaluate the expressions. For example, 3 plus 5 into 2 division 3 minus 4 into 6 plus 2 division 5. Assuming that this is one expression, how it gets evaluated? The expression is evaluated using left to right rule first. Left to right rule. Then operator precedence. Operator precedence is applied. Operator precedence, right? This gives the priority which operation gets executed first. In your school days, right, you might have seen bracket of, then division, multiplication, addition, subtraction, rule, right? Board-mask rule. Same way here, if anything, right, mentioned in this parenthesis, this is said to be parenthesis. Opening parenthesis, closing parenthesis, or parenthesis, right, rule. If you have anything, right, mentioned in the inner parenthesis, expressions inside the inner parenthesis gets evaluated first. In case if you have more than one inner parenthesis, that the rule is from left to right. Left inner parenthesis gets evaluated first. Then the next left, right, this way, left to right rule is applied. After the left to right rule, basically in case of these arithmetic operators, division and multiplication takes same precedence. Division and multiplication takes the same precedence. Addition and subtraction takes a same precedence. So having these, how this expression is evaluated, no sub expressions are there, only one expression. So you need to think of this is like this. Only one inner and outer parenthesis, or only one inner outer parenthesis is given. This is 2 by 5, for example, 2 by 5. Now we need to apply the rule left to right. When we apply the rule left to right, what happens? We need to evaluate carefully, since division and multiplication, these are taking the same precedence. Addition and subtraction are taking the same precedence, but the evaluation is from left to right. So 3 plus then 5 into 2. Clearly, which gets more precedence, more priority, plus or star? Plus operator or star operator? Which takes more
Star operator.
priority? Star operator, because you need to look here. Star takes more precedence than addition and subtraction. So I write simplification. 3 plus 5 into 2 is evaluated first. So evaluating 5 into 2, I put 1. 5 into 2 is 10. 10.
Sir,
I
2
write
by
the
3 is more
remaining
preference
expressions
no,
as it
than
is.
multiplication.
10. Left to right, division and multiplication takes the same precedence, but expression is evaluated from left to right. Left to right, first to right, multiplication is there. So 5 into 2 is evaluated. Then the result is divided by 3. Clear? 4 into 6
Yes.
plus 2 division 5. No, the rule is not division first, then multiplication second. Multiplication, division, right, same hierarchy, right, same priority level, but apply this rule left to right. That is important. Likewise, addition and subtraction, right, the rule is same from left to right. So 5 into 2, right, I put 1 to indicate this is evaluated first. Then there is no expression inside the inner parenthesis. Again, right, if you apply the rule left to right, we have the operators plus and division. Now what happens? Plus and division. Which one takes higher priority? Division takes higher priority. So 10 division 3, this is evaluated. Next, I write the evaluation here. 3 plus 10 division 3. This is what right here, this is earlier. Numerator is integer, denominator is integer, integer by integer. Integer evaluation is carried out. So 10 by 3, what happens? 10 by 3, integer portion 3 is taken. Fractional part will be lost. In case if you have used 10.0 or 3.0 or even 10.0 by 3.0, then only the fractional arithmetic is carried out and the entire expression is type promoted to the floating point evaluation, right? That is the automatic type promotion or rules. So in our case, 10 by 3, simply 3 is taken. Then I write the remaining expression first as it is. 4 into 6 plus 2 division 5 Can you tell me which is the next expression to be evaluated? Three plus three or 4 into 6 or a 2 division 5 or some other
6
operation. We may
minus
also think 3
24,
might,
like that it will
yeah,
be.
left to right rule. Please think this priority slash star same plus minus next. So find rate where star and slash, here star, here slash, left to right rule. So let us evaluate the next stage operation. 3 plus 3, yeah, minus 4 into 6. Okay, 4 into 6. This is the third right evaluation. So write 3 plus 3. Don't put here 3 plus 3 is 6. Even the result is correct, but the order is right. That's not an order. We need to follow the correct evaluation. 3 plus 3 minus 4 into 6. What happens? 24. I write remaining as it is plus 2 division 5. Next, what is evaluated? Plus or minus or this plus or division. Which one gets evaluated next?
Sir, first plus will get evaluated.
Why? We have the operators slash and star here, right? Slash and star takes higher precedence than
The
plus
division will
and
be solved
minus.
first.
So
Yes, division
check
will be
if,
solved.
yeah, division and multiplication is there. Yes, division is here. So this is evaluated next. Even if you put 6 minus 24, right, the result will be okay. But the evaluation is division is carried next. We are following left to right. So next right, I write, not writing here 6 directly, right? 3 plus 3 minus 24 plus 2 by 5. 2 by 5 means numerator is integer, denominator is integer. So result right 0, right? Integer portion 0 is taken. So I put 0. Next stage 3 plus 3. What happens? What is the confusion?
6 minus 24 it will
No
take.
slash, no star. Plus minus. Plus minus rule is from left to right. So we can sketch 3 plus 3 as the fifth evaluation. 6 minus 24 plus 0. Next, left to right, 6 minus 24. Sixth evaluation, that is minus 18. May write a plus 0. Then sketch minus 18 plus 0. Finally, this is the seventh evaluation. The result is minus 18. So this way the expressions are evaluated. In case if anything is right available inside the inner parenthesis, that inner parenthesis is evaluated first. When you have more than one inner parenthesis, the flow rate again starts from left to right. Understand? Have any doubts in this expression evaluation?
No, sir.
I have one more example. Two plus 5.2 into 2 minus 6 by 3.0 plus s.
Sir, can you show the previous slide
Yes,
also?
tell me. Yeah, wait. Yes, tell me.
Okay, sir. Okay, sir. Thank you, sir.
Okay. See, in this case, the some numbers are right fractional numbers, floating point numbers. Some are right integers. So we can directly find this is one expression, parenthesis. Then division 2 minus 5 into 3.0. As our rule, the expression inside the inner parenthesis is evaluated first. Sorry, here this is evaluated first. So here it seems one inner parenthesis, this is given. In that, the applicable rule is left to right. We need to find the evaluation based on these operators. So what happens? Shall we evaluate 2 plus 5.2 into 2? What happens? 5.2 into 2. For example, this is 10.4. Then minus 6 by 3.0 plus 2.8 division 2 minus 5 into 3.0. Next stage 2 plus 10.4. What happens? 6 by 3.0. 3.0 floating point value 6, right, is type promoter to floating point 1 as 6.0 by 3.0. So we have the quantity 2 here. The 2 is 2.0 plus 2.8 division 2 minus, we write 5 into 3.0 is not 15.0. Then this is plus minus plus expression inside the inner parenthesis. This is the expression inside the inner parenthesis. So this is evaluated, right, normally left to right rule. 2 plus 10, right, this is 12.4 minus 2.0 plus 2.8 by 2 minus 5 into 3.0. Then 12.4 minus 2. What happens? 10.4 plus 2.8 division 2 minus 5 into 3.0. 10.4 plus 2.8. What happens? 13.2. Then division 2 minus 5 into 3.0. 13.2 division 2 6.6 minus 5 into 3.0. 6.6 minus, what happens? This is 15.0. Then what is the result?
Minus 8.8.
8 point, yeah, minus 8.4. This is the result. So finally, right, we are getting a floating point quantity. So this way, right, the expressions are evaluated when you have the lower data type like this 5.2 into 2. I mean, this is the integer one. This is the floating point one. In this case, floating point operation is carried out. Likewise, a float under a long, right, long int, the higher data type, the expression is right type promoter to the higher data type. Another one, type costing operation. Suppose int x is equal to 10 by 3. In this case, x receives a value integer portion. 3 is assigned. If you write float x is equal to 10 by 3,
3.0.
3 point something, Yeah, three good. 3.00000. This is assigned. In case here at runtime, right, if you want to convert this 10 into 10.0, style is supported in C, C++ languages. I write a float of 10, division 3. You check, right, a compilers, right, different compilers support this style also. Float of 10, division 3. This means only the numeric 10 is converted into 10.0, then 10.0 by 3. Here this float of 10 means same. 10 is converted to 10.0, then the 3 is there. So 10.0 by 3, again 10.0 by 3.0. So floating point arithmetic 3.3333. This result is assigned to the left hand side variable x. This is to be type costing. Costing, right? Type. Only in this place, float x is equal to float of 10 by 3. The expression 10 is type costed. Instead of this 10, suppose you have another variable. Suppose int a is equal to 10. How will you write? Float a is equal to, or float x. Float x is equal to float of a division 3. Understand carefully, x is the integer variable. Only when we evaluate this assignment statement, the integer variable a is type promoted to float here, but a is not converted to 10.0. But in this place, the value of a is type promoted to 10.0, but 10.0 will not be assigned in the variable a. Just to think of, in this highlighted place, 10.0 is replaced. 10.0 by 3 is taken. Then subsequently, wherever you use, for example, float y is equal to something, a plus or a into 5 means this a, right, remains the integer 1. Subsequently, after the statement, if you have this statement. So wherever you need to convert the particular value or the variable or even expression to the desired data type, we can perform simply the costing or typecasting operation. This way, the general form is data type. This should be put in parentheses like this. Then you need to write the expression. The expression is converted to this data type. Or you can put write data type within bracket expression, or data type right within bracket, then expression within bracket. Expression is temporarily right there evaluated and converted to the target data type. This is it to be the typecasting operation. Understand? Have any doubts up to this? Shall we solve the problems now? We have explored the constants, variables, expressions, right, evaluations, and operators. So now we will be able to solve, right, the problems based on these things. If you have any doubts, right, in the session, right, you can ask now. If not, right, we move on to right solving the problems. Okay, please take the problem. Next one, find the maximum and minimum of three integers. Already we have written the pseudocode, the flowchart, run the flowchart algorithm. Now let us convert, write that into the program using the concepts right so far we learned. Please include the header file, hash include stdio.h int main, find the maximum and the minimum of three integers. Let us declare the integers int a, comma b, comma c, assuming that the variables max and min are required to assign the maximum and the minimum of the three integers. Then we need to get input into the variables a, b, and c. So I write a printf statement, printf slash n, enter the integers a, b, c. How do we write as input statement? Scanf. We can write three scanf statements: scanf percentage d ampersand e. Otherwise, we can write in a single statement to have three input integers: percentage d, then percentage d, comma ampersand a, ampersand b, ampersand c. Three integers are obtained. Then we can compare a with b, a with c. So write the simple if statement as illustrated right in the algorithm. If forming the relational expression if a greater than b and a greater than c, then in this case max is equal to a. Else if b and c needs to be compared, b and c right need to be compared. Else if b is greater than c, then max is equal to b. Else max is equal to c. We can print the maximum. Likewise, right, you can find the minimum, right, by writing the code. So I write only the maximum. Printf slash n. Maximum is percentage d, comma max. For int main, use return 1 or return 0. Save the file, save, I think cp13 F9, program is successfully compiled. Control F9, enter the three integers. I write 1, 2, 3, maximum is 3. Control F9, I write to be 1, 3, 2, maximum at the second position. Maximum is 3. Control F9, 3, 1, 2, maximum at first position, maximum is 3. Control F9, all integers are same, maximum is 5. So a greater than b, this is one relational expression formed using the relational operator greater than. A greater than C, this is second relational expression formed using the relational operator greater than. Double ampersand, this is the logical AND operator. This combines the two relational expressions to form a logical expression. The result of logical expression is either true or false. So if A is greater than B and A is greater than C, then A is ultimately the maximum. Maximum is E. If the condition fails, that means A is not a maximum. Clearly, we need not compare. Please understand here, we need not write B greater than A and B greater than C. B need not be checked with A again. Only B and C, right? Comparison is enough. Because A is not a greater quantity. Ultimately, either B or C will be greater. Hence, else if write B greater than C, this is enough. If the condition results in true, maximum is B. Else, A is not a greater quantity, B is also not a greater quantity. Logically, C is a maximum one. Hence, in the else part, without checking any condition further, we can directly say C is a maximum quantity. This is the way, right, to convert the, or to write or to introduce the relational expression, logical expression, right, with respect to the conditional statements, if else statements. Understand? Have any doubts in this example? Any doubt?
Sir,
Yes.
sir, we can also use the printf method for each max, right? Max equal to A, max equal to B, max equal to C.
For each if, okay, there we can write in each if after writing max is equal to A, there you can write print of maximum is A. Else if, okay, you need to introduce right on one thing, opening and closing curly braces again for each if else part. But thrice there you need to use maximum is. But here in this example, I introduced right only one printf statement. Whatever is, no problem. You can also use 3 printf statements accordingly.
Okay, sir. Thank you, sir.
Next example, I shared the code. Uh, the minimum and maximum of two numbers using ternary operator. Include header file hash include stdio.h name. Problem is finding the maximum and the minimum use are two numbers right? For example, let it be 14 point quantities, float xy, then max and the minimum. I write max in, or you write maximum, minimum, whatever you feel. Print slash n, enter two numbers, then write a scanf statement, and percentage f ampersand x ampersand y. Input is received in the variables x and y. And I don't want to use if statement. Instead, we like to use the ternary conditional operator. So what is the syntax ternary operator? X greater than y is restored. If x is greater than y, x should be processed, otherwise y should be processed. The result rate may be assigned to the variable, left hand side variable max. So max is equal to x greater than y, x colon y. Likewise, min is equal to x greater than y is minimum, else x is minimum. Printf slash n max is percentage f min is percentage f comma max comma min. Return is 0. File save cp14 F9. No compile time errors. Control F9. Enter two numbers 2.5, 4.6. Maximum is at the second location. Maximum and the minimum is printed. In case the first quantity is a maximum one, 5.5, second one 0.2, maximum is 8.5, minimum is 0. You can also write like this: x greater than y, question mark. The condition is true. I write a printf statement. Printf max is percentage d, comma x colon printf slash n max is percentage percentage f comma what is the maximum y. In this case, what happens? Let us check the code. F9, no compile time errors. Control F9. Two numbers 10.0 minus 10.0. Max is a 10.0, right? Additionally, right, we have the second line. Max is 10.0. Because of this effect, x greater than y, we didn't process the result to assign to the left-hand side variable. Instead, right, is simply given the general form of the ternary operator: expression 1 colon expression 2, sorry, expression 1 question mark, expression 2 colon expression 3. Expression 1, right, we have this a as a x greater than y question mark. For expression 2, we have a printf statement, and expression 3, we have a printf statement. This is also the right style. In this case, the condition is true. This is the expression to be evaluated. That means printf gets executed. If the condition is the condition becomes false, third expression after this colon, this gets evaluated. And since this is the executable statement, commonly we put a semicolon, right? So the semicolon right ends or tells, right? This is one executable statement. If you have a confusion here, you can introduce the parenthesis here also. Max is equal to, this can be written as max is equal to this way, parenthesis x greater than y, mark x colon y semicolon. Likewise here, x greater than y, if you have a confusion, x greater than y can be put in the parenthesis to signify that x greater than y, right, as a condition is tested first. If this is true, a printf statement is executed, first printf statement is executed, else the second printf statement is executed. Understand? Have any doubts in this example?
No, sir.
Next one. Please take this example. Given two integers x and y, find the result of bitwise operations. Given two integers x and y, find the result of bitwise operations and the integers, right, x and y. That is the problem. Let us write a code, right, to check the bitwise operators. Hash include stdio.h int main. All of you write into your programming skills. Int main. Define the variables. Say int xy. Let us get the input values of variables x and y. So giving a reasonable printf message, printf /n, please enter two integers x and y, write a scanf statement. Scanf percentage d percentage d ampersand x ampersand y. Then we need to find the bitwise operations, right? We have explored the various bitwise operations. What are they? Bitwise and bitwise are, bitwise not, bitwise XOR. Let us execute, right, these operations for the keyboard inputs, say x and y. Printf /n x and y. I write in short colon comma x and y. X and y, right? This is evaluated. The result is printed directly. Here, this is the expression, right? Percentage p format specifier. Percentage d replaces the value of x and y. Or if you have a confusion, have another variable, say z. You write z is equal to x and y. That is also correct. Here this x and y is replaced by z. Right? Here I already said, right, don't use ampersand in the printf statement. Here this ampersand, right, signifies bitwise operation on the variables x and y. Likewise, I use copy paste, edit, copy, shift insert, shift insert, shift insert. Okay, this is x or y. Quite simple, right? I typed it here. It looks like this, a vertical line. Then and r, what is missing? XOR. XOR is this one. Tab symbol. X. Below, sorry, above 6, we have this key. XOR y. And r XOR, then not is the what one? One's complement operator. This is the tilde symbol. But tilde symbol, right? I have a problem in my keyboard. So I set right tilde symbol to have a value yes. I need to get it from Control C, edit, paste, OK. Tilde X, Control OK. This is paste. Shift insert. OK. Tilde X. One's complement of X is printed. Likewise, edit, copy, edit, paste, tilde Y. That is one's complement of Y. Then return C. Let us check the code. File save CP F15 F9. Good. No compile time errors are reported. Control F9. Let us input two integers. Let us check our results also. What we have taken x is equal to 5, y is equal to 7. Let us input 5 space 7. X and y is 5. What we have obtained earlier, yes, x and y is 5. X or y, right? We have obtained as 7, right? So x or y is 7. Likewise, right? If you do the trace using this table for XOR operation, you can verify, right? XOR y is equal to, then one's complement of x is minus 6, one's complement of y is minus 8. You can ask, right, how these negative numbers are coming, right? We have the corresponding one's complement. So when you take the one's complement, right, 0 is converted to 1 and 1 is converted into 0. What you have to do, you need to check if the MSB, most significant bit, that is 1. When the most significant bit is 1, that is an indication of a negative number. When you have a negative number, remaining 7 bits, right, should be represented in the 2's complement form. So if you decode into the equivalent, right, or decode from these the 2's complement or convert, right, the equivalent to 2's complement, to actually decode that, you will get a value 6. So that you will get a value minus 6. Likewise for y, right, one can verify, you can get a result minus 8. So in this example, we have illustrated the basic bitwise operators and OR, XOR, then the ones complement operator, not operator. Likewise, you can implement the logical operators, logical and, logical or, logical not, to verify this table, logical and, logical or, and logical not. Have any doubts in this example? Have any doubts?
No, sir.
If you have any doubts, you can ask. Okay. Can you write a program to find the maximum of three integers using the ternary operator? Or shall I solve? Uh, Let me save the file. Okay, next one. New. Let us complete two more programs. Please wait. Find the minimum of three numbers using ternary operator. Hash include stdio.h into main. Ternary operator is introduced here. Declare three variables, say int a, b, c. Let us check right if min is required. Okay. Print up hash and enter a, b, c as three integers. Then have a scanf statement. Scanf percentage d, percentage d, percentage d, ampersand a, ampersand b, ampersand c. Or enter three integers. Or change it to right floating point numbers. No problem. Percentage f, percentage f, percentage f. Can you tell me right how to compare right three numbers with the ternary operator?
X less than y, x less than z, then y less than z like that.
There are different ways. Yes, one can write min is equal to comparing right a and b, a greater than b and a greater than c, question mark a colon. Then the false part checking if what is the minimum or maximum. So right to
Less than
sorry,
simple complex.
yeah, less than simple. Yes, a less than b and a less than c. Right, a is the minimum. Else, right, I put here one parenthesis, right, to signify our false block statement. So I write here b less than c question mark b colon c. I end with semicolon. First, let us check this. Okay, okay, parenthesis. Okay. Then here, min is equal to. Let us verify the result, right? Print of slash n min is percentage d comma min. Return 0. F2 save the file. Save as I think CP16. F9 no error. Control F9. What happened? Control F9. Int ABC, but the format specifier is float one. Because of that, right, program will not get executed. Control F9. Okay, change it to right. Enter ABC. I changed right from int to float. That's what here we didn't see the runtime screen. Enter ABC. Have you noticed that I changed right suddenly int ABC to float ABC because here the format specifier is percentage f. Okay, enter ABC 1.3, 4.6, 5.8 something. Minimum is 0. Incorrect result. This will be changed to percentage f. Control F9 1.2 something. Okay. Minimum is 1.2. Likewise, check if when minimum occurs at the second position. Control F9. 2, 1, 3. Minimum is 1. And minimum is at the third position. 1, 2, 0. Minimum is 0. Here, right, check if this parenthesis necessary. I remove the parenthesis. Control F9. 1, 2, 3. Minimum is 1. Control F9. 2, 1, 3. Minimum is 1. Control F9. 3, 2, 1. Say we checked right minimum at 3 different positions. Have you noticed here I have removed the parenthesis, but it seems a confusing statement because from left to right itself A less than B and logical and A less than C, question mark. Question mark is a ternary operator right here. Clearly this logical and takes first precedence, right? Priority, then the less than operator. So I highlighted here double ampersand. This takes the highest priority here. To evaluate this double ampersand, left hand operand A less than B is evaluated, then A less than C is evaluated. Then the combined logical expression is evaluated because double ampersand is the logical and operator. Then coming to this ternary operator, is the highlighted logical expression results in true, its true block statement is or true block expression with respect to our syntax here is expression 2. Expression 2 is, for example, this is not a printf statement. If you want, you can use a printf statement here. Simply A. If this is true, then expression 2, this is the expression 2, A is assigned to the variable minimum. In case if the highlighted expression, expression 1 results in false, this is the false block expression, same as expression 3. Now expression 3 is evaluated. Understand clearly, A less than B and A less than C is false. Highlighted expression, that is expression 3 gets evaluated now. To evaluate expression 3, again we used the ternary operator. Hope you understand. That means we have placed the ternary operator in the expression 3 also. That is also valid, right? Acceptable. So if B less than C, third expression, to evaluate expression 3, since this is based on a ternary operator, again checking the result if B less than C is true. If B less than C is true, its a true block expression B is evaluated and the result is assigned to the variable min. Else the expression rate C or the variable C is assigned to the variable min. So this is also a correct one. In case if you have a confusion, right, try to include the necessary parenthesis. Copy, right, edit, paste. Here I comment here, write this way, A less than B and A less than C. This is
Sir?
A, then B less than C, B and C. Yes, tell me.
Sir, can you also write separate and write it for minimum for me?
Can't get you. Please, once again.
Sir?
Yes, tell me.
Sir, can you show the slide once again? I'll see it.
Slide or coding?
Coding, sir, coding.
Okay. Yes, tell me.
Sir, that's this means that minimum is equal to the conditional state, right? Is that right?
Yeah.
Can we separate it into two parts and write it?
How do you separate?
So for the first part, A less than B, and for the second part, B less than C, like that, like that.
In the ternary operator, in a single statement, right, this is one possible usage. A less than B and A less than C, a question mark, A, colon, then expression 3 is required in this case. So logically, right, we check the B and C using a ternary operator. Or if you want, right, can you tell me the expression so that I can type?
No, sir, I'm asking doubt whether we can write or not.
Yeah, how can you separate this part into two equivalent parts? That is the question. One thing you understand first, when you introduce the question mark, two expressions are required. Before the question mark, one expression that actually evaluated first, so that control is transferred to any of the two branches, either to expression 2 or expression 3. That stage, you must have the true black expression, colon, false black expression. This is must. In case if anything is missing, that results in a compile time error. So try yourself, right, by finding the separation of the true block or false block alternatively. But anyhow, you should have the expression 2 as well as expression 3. So I don't, I am not getting you exactly. So you try to write the expression, right? Then run the code. In that, right, you should have the applicability of expression 1 colon expression 2 colon expression 3. But if anything is missing, then it leads to a compile time error. Any other doubt?
Okay, sir.
Vigneswaran, you try to check, right, by splitting that into some two parts and check if you have included, right, correctly expression 1, expression 2, expression 3.
Okay.
If it's so right, it will work. Otherwise, compiler results in the error message.
Okay, sir.
So in this session, in this session we have focused on the operators, different kinds of operators in C language, up to, right, the ternary operator and evaluating expressions. Based on this, we have solved some problems. Please go through the session carefully. I post the material, right, after some time. Tomorrow and day after tomorrow, right, Saturday and Sunday, right, we go through this carefully. Then we discuss the control statements. The core part is control statements in C language. Conditional control statements, unconditional control statements, right? We need to go through that. Then we can solve, right, the problems, right? Fibonacci numbers, the Fibonacci numbers, GCD, right? While loop, for loop, then factorial, the problems, right, that we have discussed earlier, right? So that those problems can easily be converted into the equivalent C program. So before that, right, I post, right, some problems, right, in the GCR without using the control statements, but logically, right, using like this variable declaration, normal expression evaluation, getting the inputs and processing the result and printing the result. So you need not use any of the conditional or unconditional control statements. Without that, right, you can easily solve the problems. So that I post some of the exercises in GCR. So please go through that and try to, right, find the equivalent programs, right, work, solve the problem and find the result. And you try to show it me on the next class. Have any other doubts? Shall we wind up the session now?
Yes, sir.
Okay, thank you very much.
Thank you, sir.
Thank you very much. Prepare
Thank you, sir.
well. Take care. Thank you.
Thank you, sir.
Thank you, sir.